Hi everyone. So for those of you who are using Python, here's the corresponding code in order to, or sample code, in order to create your own animation. So the idea here is that first I'm going to generate a sine function, and I'm going to put a dot at the beginning of a sine function and allow that dot to go and move through the sine function. I'm going to show you later what I mean. So first I need to to generate the sine function. So to do that, I use this variable deg to create 360, or to assign the value 360. This deg is the degrees, or the number of degrees that I want for my, or the number of intervals that I want for my sine function. The step size for the step function is 1 degree. In other words, I'm doing the sine function for the sine function is a value for every degree. Next is this t determines the time for the sine function, and then here I assign the sine function as a current. This is my sine function, and it's simply the sine of t. And since this sine function takes in only radians, and t here is assigned as degrees, so I have to convert it to degrees. So the conversion is pi over 180. Okay, so now these four commands here generate the sine function. This command here will generate, um, sorry, I have to uncomment this. Okay, so this command here will generate the sine function. Now, what this command does is to create the circle, or the marker, which will go and travel through the sine function. And you notice that I created this for loop because I want each point of the sine function to to go through the curve for each iteration. So I begin with I equals 1, which corresponds to sine of 1 degree, and then I equals 2 corresponds to sine of 2 degrees, and so on and so forth. So the dot will move step by step and use the sine function as a path, or follow the sine function as the path. And you will see that later. So these two just defines the limits of the axis of the graph. These just define the ticks of the along the x-axis. This defines the grid, and of course we have to do this. We have to add this in order to show the plot. Okay, now I have this command, and what does this command do? So this command tells Python to pause, or in this case to sleep. So it doesn't do anything for 0.01 seconds. Okay, so any number that you put here corresponds to the time in seconds. So if you put here 3 seconds, this for loop will stop for 3 seconds each iteration. Okay, now what does this command do? So this command takes a snap picture, or a picture of the frame at each iteration of I, or at each degree. Okay, so it saves that file to this camera pointer, okay, which is identified through this camera uh, command, okay, which we got from the library or module called celluloid. Now, when you run this, your version of Python may not include celluloid, the module celluloid just yet. So you have to install the celluloid module first, and you do that by copying this and then just typing it, or pasting it, sorry, or just pasting it in the command module, okay, like so. Okay, and then just press enter. Okay, I don't need to do that anymore because I've already done that. And once you've entered that, it will install the module celluloid. And if you're using Spider like I am, just click this X button, and you should be able to. That should be enough to restart the console. Otherwise, just restart your Spider or your um, Anaconda application. Okay, so now that we know that what this does, okay, the next thing to do is to do the animation, and Python will do it using this command animate. Okay, so now let's try to run this and see what happens. Now the red dot is traveling 1 degree at a time. Okay, so that command was generated, or this movement was generated by this command here. And the reason why it moves because we're doing it in a for loop. So I'm doing the for loop from the index 0 up to the index 359. Okay, so let's just wait for this to finish. Okay, now that the program is finished, okay, you already know how to do an animation in Python. Just one last thing, I made this a small error here. It should be without the open close quotation marks, single quotation marks, but in any case, um, the program still ran, and the only reason why we don't see this x-axis here is because of this error here. Okay, so notice that when I made the correction, the ticks, the X ticks are already present. Okay, so good luck, and if you have any questions, just feel free to ask me during consultation hours or just send an email.